Welcome to Lesson 7, Array-Oriented Programming with NumPy. NumPy is one of the most important scientific computing libraries out there for the Python programming language, and it turns out that many other Python libraries are actually built on top of NumPy as well. And one of the reasons for that is its super high performance data structure known as an ND array, which is what we'll be studying here in Lesson 7. These ND arrays are up to 100 times faster than the list data structure that's built into the Python language itself. So in this lesson we'll talk a bit about how ND arrays differ from lists. We're also going to compare their performance so that you can actually see up to the 2 orders of magnitude difference in performance. And to do that, we're going to introduce something in IPython that's known as a magic, which is an IPython specific command. In this case, the timeIt command, which is going to enable us to time the performance of a statement as it executes. We'll show you both one-dimensional and multi-dimensional ND arrays. And the most important thing that we're going to see in this lesson is a bunch of common ND array manipulations. And one of the things you'll see is that a lot of those manipulations can be applied to every element of an ND array at the same time. So we already saw lots of list processing, and as you know, we either iterated through a list using a for loop and touching each element one at a time, or we might have used, for example, a list comprehension, which still touches each element one element at a time sequentially. But with ND array manipulations, a lot of them can be parallelized on the multi-core architectures of today's computers, and that enables them to execute with a much higher level of performance. In Lesson 7's Intro to Data Science section, we're going to take a look at a library called Pandas, which is used frequently in data science studies for data manipulation and a concept called data wrangling and data preparation, where you're trying to get the data into the form you need for use in your studies. Now, this particular Intro to Data Science section is the first of 3 in which we introduce various features of working with the Pandas library. In this section, we're going to talk about the 2 key data structures that are part of Pandas: the one-dimensional series data structure, which is similar to the concept of a one-dimensional list, and the two-dimensional data frame data structure, which is similar to the concept of a two-dimensional list, or similarly a one-dimensional ND array and a two-dimensional ND array. Now, we're going to demonstrate some interesting features with Pandas, including the fact that you can customize their indices. So when you're working with a list or an ND array, indices always start from 0, and if it's a multi-dimensional list or ND array, then the rows, for example, have indices starting from 0, and the columns have indices starting from 0, and of course you can have more dimensions beyond that as well. Now, with series and data frames, you can certainly have indices that start from 0, that is the default, but you also have the ability to specify for example, categorical indices, where let's say you had a data frame that represented a bunch of students in a class and a bunch of exam grades. You could have, for example, each column in the data frame represent one student, and you could actually use their name as the index for that column. We'll demonstrate some basic descriptive statistics calculated for all of the data in a series or a data frame, respectively. And as you'll see, there's one simple method call that will produce those statistics for you. And finally, we'll also do a little bit of data formatting customization. It turns out that both NumPy arrays and Pandas data structures like series and data frames have built-in output formatting capabilities that can display the data in a very nice look and feel on the screen. And that is something that you can customize as well. So for example, when you're displaying floating point numbers, as you probably know, you can sometimes have many digits to the right of the decimal point, but you may want to, for example, reduce the number of digits to 2 or 3 to the right of the decimal point so that you have some uniformity in the output that you're displaying. So we'll demonstrate how to do that here for Pandas output formatting.